let's look at this question with a slightly simpler example to start with. So the LCM of 12 and 10. Well, a common multiple of 12 and 10 is going to be if we multiply them together to give 120. The question is that the lowest common multiple? And the answer is no, because I can write 12 as 2 times 2 times 3. And I can write 10 as 2 times, let me do the times a bit further on. 2 times 5. Now, a common multiple of these two will have to be in the 4 times table because of the 12 here. And it will have to be in the 2 times table because of this 10 here. But it doesn't have to be in the 8 times table because a multiple of a common multiple will already be in the, you'll guarantee that you're in the 2 times table when you're in the 4 times table, basically. And so what we tend to do is we tend to circle these and just deal with this one once. And so the answer for the LCM is actually 2 times 2 times 3 times 5. I'll just try and explain the logic before I then just complete this question. So basically, a common multiple of P and Q would be if I just multiplied them together, but I don't need to multiply them all together because my multiple, if it's in the 2 to the 5 times table, it would already be in the 2 to the 4 times table. So I'm just taking the largest of the powers, basically. I can do the same for this one. My multiple will be in the 9 times table, so it will already be in the 3 times table. I don't need to multiply all of those 3's together. So it's going to be 3 squared. And then, now I need to deal with this one because this is in the 5 cubed. The multiple will be in the 5 cubes times table, the common multiple, but it has to be in the 5 to the 4 times table, which is already in the 5 to the 3 times table. So I just take that larger power, and then I can times by 7 and 11 because my common multiple will have to be in those times tables as well. For this sort of question, it doesn't say to leave it in product of prime form, which I'm quite surprised by because it does say below. So I think it pays to just write it as a number as well. 1386 and then with 4 zeros. I'm pretty sure I'd get away with it for just leaving it as a product of prime factors, but here I've written the number out in full. So some ways this is sort of taught is as I did here. I might actually write out these numbers in full. It's 2 times 2 times 2, and then circle them. And you basically do the circled ones times the ones by themselves. Sometimes this is taught using a Venn diagram. Write the shared factors in the middle. And we could do it quickly, I suppose, by writing 2 to the 4 and 3 squared, etc. And then writing the other ones either side, and then you multiply all of that together. But this is the quickest way, just finding basically the highest power that goes into one of them, if that makes sense. If we've got a 2 to the 5 and a 2 to the 4, then we take the 2 to the 5. Right, now we've got another number, C. And it's written the product of prime factors, C equals 2 to the 3 times 5 squared. Work out P divided by C. I'm going to write it as a fraction here. 2 to the 5 times 3 squared times 5 cubed times 11 divided by 2 to the 3 times 5 squared. Now what I can do is I can basically just start cancelling things out. I can divide top and bottom by 2 to the 3, and that will go partially with this, and I'll be left with 2 squared. You can see it using the idea of equivalent fractions, or you can just say, look, it's going to cancel it out like that. The 3 is going to cancel out the 3 squared bit, but I'm still going to be left with the 3, and the 5 squared is going to be cancelling out that cubed bit. I'm still going to be left with the 5. So my final answer will be 2 squared times 3 times 5 times 11. And it's asked me to leave it as a product of prime factors, so that's my answer. That should go down there. Whoops. Okay, a bit more to do on this, right? 450 is a product of its prime factors. So there's a quick way of doing this. I mean, this is a calculator paper, and this is 3 marks. It's expecting some working, but you can actually do it really quickly using 450 equals and then pressing shift fact, and it does it all for you. 2 times 3 squared times 5 squared. Now, I think that's a very risky game to play in a in a GCSE paper, you're expected to show working. So I would go through the process of doing the factor tree. Okay, circling prime numbers once you get them. I think I just made a mistake here. Why did I go with 15 times 10? Sorry, shocking. It should be 30 here. Okay, there's lots of different factor trees you can get. 2, 15, circle the 2, 3, 5. So I can get it that way as well. Now I would like to see that bit of working for this question. Find the highest common factor of 270 and 450. Well, that doesn't link to here at all. We're going to need to now find find 270 as a product of prime factors, but because this is, we can just use our calculator for that for sure. 270 equals shift fact 2 times 3 squared times 5. I think actually it's 3 cubed, sorry, times 5. Okay, now the highest common factor is the highest number that goes into both. I think I'm going to do this one using a Venn diagram method. So if I write 270 here and 450 here, then I can see they've got a shared factor of 2, and then 450 has an extra 2. They've got a shared 3 and another 3, and then 270 has an extra 3, and they both have a 5. And that basically, this intersection of the Venn diagram tells me the highest common factor, because 3 goes into both of them at least twice, 5 goes into both of them once, and 2 goes into both of them. But whereas 4 goes into 450, it doesn't go into 270, so I can't use that. My answer is going to be 2 times 3 times 3 times 5, which is, the best way of doing this would be without a calculator would be 2 times 5, which is 10, 3 times 3, which is 9, and so it's going to be 90. There are lots of ways of doing this question. You can actually get away with, well, you don't really want to be finding all of the factors for these numbers. They're too large, so that method's out the window. Another quick way of doing it is to write it down. Write these down a bit more fully. 2 times 3 times 3 times 3 times 5, and 2 times 2 times 3 times 3 times 5. These are my two numbers. And then you circle the shared ones and multiply those together. That will also give you 90. Just trying to give some different ways of doing this question. In any case, the answer is 90.